It's quite a lot to question 60 here. So we'll start off with drawing our diagram. We've got an 8 kilogram particle here joined by a light inextensible string to a 5 kilogram particle here. It's being pulled by a force of 300 newtons, and we've got a resistance force, a friction of K on that one, and also a friction force of K on that one there. In this cable here, there's some tension pulling this one back, and there's some tension pulling this one forward. This one's A, and this one's B. So we'll start off with our force diagram like this. And what's happening at A? Well, pulling A forward to the right here is T, and stopping it moving is the friction of force K, and force equals mass times whatever the acceleration of this is going to be. Let's do the same at B as well. At B, pulling it to the right, we've got the 300 newtons, take away the tension, and also take away K, and that equals the mass times the acceleration. And if we add those two equations together, you'll see the T's cancel out, and we get 300 minus 2K equals 13A. I'm going to park that there for a little bit, because we finished with our forces diagram. Now we need to use some Suvat work, because it says it starts with velocity of 0. It says it starts at rest. I don't want the final velocity just yet. I'm going to need that later. I'm going to figure out what A is, because I'm going to need it here. It tells us that S is 28.8, and it tells us that it was accelerating for 2 seconds. So using these values here, and an S equals ut plus half at squared, I can fill in the values we've got. That's nice, that one's just 0. 2 squared's just 4. I can figure out here that the acceleration is 28.8 times by, or divide by 2. So the acceleration is 14.4 meters per second. Let's put this value in up here. So I've got 300 minus 2K equals 13 times 14.4. That's 187.2. And so I can figure out now that K is equal to 56.4 newtons. Well, if I know what K is, I can then put it straight back in here to find out what the T is. So I've got T minus 56.4 equals 8 times the acceleration, which I've got is 14.4. And so I've got T to be 171.6 newtons. Part C says, well, how did you use the fact that it was light and inextensible? Well, that's because the A I'm using here is the same as I'm using there, is the same there as the same there. So we've used the acceleration the same in all places. A little note on why I made that bit quite so easy is because I started with these formulas here. I know what's coming in the second year. I want to be writing 2 formulas and solving them simultaneously rather than working it all out as one big thing. Now, part D, there's still 7 marks to go. I'll stop here and do it as a second video.